Okay, so we've got a longer video this time, and it's called Float Times and Later Start Times. So a float time is the difference in time between those paths that cannot be delayed and those paths that can be delayed. Okay, so floating is the difference in time between those that cannot be delayed and those that can be. And the later start time for activities that can be delayed is defined as the later start time the activity can be begun, that can begin without delaying the whole project. Okay, so we're going to work through examples so it'll make more sense. Copy that and when you're ready, come across. Okay, so from a previous video we've got this diagram. We had, for instance, activity to get to this node here, D to E took 8 minutes, B only took 2 minutes, so that means activity B has a float time of 6 minutes, float time of 6 minutes. So like we had to get to that node there. Activity G only took 1 minute, but the float time to get to there, the time to get there was 8 minutes. So that means that activity G has a float time of 7 minutes. Because DE is on the critical path, it cannot be delayed, so it doesn't have a float time at all. So if activity B has a time of 2 minutes, and to get to that spot there was 12 minutes, the latest that B can start is at the 10-minute mark, because the 10 plus 2 equals 12. So we had 12 minutes at that spot there. Just putting the numbers back in again, we had 0, 4, 8, 12, and 18, and 20. Okay, there were the numbers we had. So because we've got the 12-minute mark, and this takes 2, so B can start at 10 minutes, and G can start at the 11-minute mark and still get to the 12-minute time frame along the way. Okay, so copy that and come across. I think let's see what's the next slide. Okay, so what we've got a little bit of notes to take down. So critical path analysis with backward scanning. So this is the formal method to find the critical path. So I've got CPA for critical path analysis. So the requirements for critical path, 2 nodes can be connected directly by a maximum of 1 edge, and activity must be represented by exactly 1 edge. Okay, that's just requirements for critical path. 2 nodes can be connected directly by a maximum of 1 edge, and an activity must be represented by an edge. So backward scanning starts at the end node and moves backward through the network, subtracting the time of each edge from the earliest start time of each succeeding node. So when we look at an example, it'll make a lot more sense. When 2 or more paths are followed back to the same node, you take the smallest such difference is recorded. Okay, that's recorded, that word. Okay, so copy that, and hopefully the next page we might have an example. I'm not sure. We'll see. So copy that, come across. Oh no, some more notes. The results of each backward scanning step yields the latest start time for each activity. The latest start time is the latest start an activity can start without delaying the whole project. So we had activity B and G before, had latest start times. The earliest finish time for an activity is equal to the latest start time of the following activity. So we're going to end up with this formula. So the float time is the earliest finish time minus the earliest start time minus the length of the activity. And again, it's not making a lot of sense now, but once you see an example, it will make a lot more sense. So copy that and come across when you're ready. Okay, so we've got an activity. So we've got a new activity. So we've got noughts, 3, 5, and then 5 plus 2 is 7, 3 plus 6 is 9, so 9 is the finishing time. So that number we can now transfer into there, and then the earliest start time, so we go backwards, so 9 minus 6 is 3, 3 minus 3 is 0, 9 minus 2 is 7, so this means that we can start that activity at the 7-minute mark and still make it. So activity A, early start time is 0, earliest finish time is 3, and it's on the critical path, so it has no float time. Activity B, it's the earliest it starts at 0. The earliest it can finish. Okay, so we've got now the earliest finish time is also the latest start time of the following activity. So activity B, the latest earliest finish time is the latest start time, which is 7, and so 7 minus 0 minus 5 is 2, so B has a float time of 2 minutes. Activity C, the earliest start time is at 3 minutes. The earliest finish time is at 9 minutes. So 9 minus 3 minus 6 is 0. So once you've got zeros, that becomes a critical path. And activity D, the earliest it can start is at 5 minutes. The earliest it can finish is at 9 minutes. So 9 minus 5 minus 2 is 2. So that means activity D and activity B both have a float time of 2 minutes. Okay, so this thing here, the earliest finishing time is the latest start time, are these numbers underneath. Okay, so come across when you're ready. Okay, so we've got a more complicated diagram. So we're going to try to fill in activities. So first thing we'll do is we'll put in the numbers. So activity A is 3 minutes, activity B is 4 minutes, activity C is 6, activity D is 15, activity E is 4, F is 7, G is 2, H is 4, I is 2, J is 3, K is 4, M and N is 3. Activity A doesn't have any predecessors. Activity B doesn't have any predecessors. Activity C, to do C you must have done B. To do D you must have done A. To do E you must have done A. To do F you must have done E. To do G you must have done E. To do H you must have done C and G, both going to that point. To do I you must have done F and H. To do J. To do J you must have done D and I. To do K you must have done I and D. Same again. To do M you only have to have done J. And to do N you only have to have done K. So that's the first part of it. So let's go through and put our forward scan, put our numbers in. Okay, so we've got 0 to start with, and then 3 and 4. To get to E, we've got 7 there. Now 7 plus 2 is 9, 4 plus 6 is 10, so we have to write the 10. The 9 is the smaller number. Okay, to get across the top, 3 plus 15 is 18, so I'll put 18 there. We've got 10 plus 4 is 14, 7 plus 7 is 14, so we've got a tie, so we can put 14 in there, if that's okay. 14 plus 2 is 16, but 18 is already there, so 18 can come across. 18 plus 3 is 21, there's no other spot to get there. 18 plus 4 is 22, so there's no other way to get to there. 21 plus 3 is 25, so I can put 25. 21 plus 2 is 23, so so you write down the bigger number. Okay, so that is going to be, the earliest finishing time is 25 minutes. So now we just go backwards and subtract numbers. So 25 minus 3 is 22. 25 minus 2 is 23, so there's a float time there. 23 minus 3 is 20, but 22 minus 4 is 18, so you put the smaller number. Okay, so that becomes the critical path again. So when the numbers match, numbers match, that's going to be the critical path. Okay, so to get down to here, 18 minus 2 is 16, so that's not the critical path. 18 minus 15 is 3, so that's going to be on the critical path up there. Now we can be careful here, 16 minus 4 is 12, so that's not on the critical path. 12 minus 6 is 6, so that's not the critical path. Let's just check this. So 18 minus 7 is 9. 12 minus 2 is 10, but you put, so we've got 9 and 10, but you put the smaller number down. We've already finished that path up there, and where we start is 0. So now we can match up and have any time where the numbers match is the critical path. So like that, up, across, and down. So that's the critical path. Now we can work out our float time. So I think there's going to be lots of 2-minute float times. Earliest start time for A is 0. Earliest time for B, 0. Earliest start time for C is 4 minutes. Earliest finish time for C is at 6 minutes. Just going to pause for a sec, hang on. So the earliest start times are the numbers at the top of the little houses. So activity D is 3, activity E is 3, activity F is 7, activity G is 7, activity H is 10, activity I comes from 14, activity J is at 18, activity K is at 18, activity M is at 21, and activity N is at 22. Okay, so the earliest finishing time is the latest start time, which is the numbers at the bottom. Okay, so A is at 3, B is at 6, C is at 12, activity D is at 18, activity E, so we're going from E, so it's going to be 9, activity F is at 16, activity G goes to 12, H goes to 16, I goes to 18, J goes to 23, K goes to 22, M goes to 25, and N goes to 25 as well. And now we just go 3 minus 0 minus 3 is 0, 6 minus 0 minus 4 is 2, 12 minus 4 minus 6 is 2, 18 minus 3 minus 15 is 0, 9 minus 3 minus 4 is 2, 16 minus 7 minus 7 is 2, 12 minus 7 minus 2 is 3, 16 minus 10 minus 4 is 2, 18 minus 4 is 6. So that's 0, 23, 5, 3 is 2, 4 is 0, 21, So that's 4 is 2, 25 minus 2 minus 3 is 0. So anytime you have a 0, that's on the critical path. So all these zeros are the critical path. Okay, I think we've got one more thing which isn't critical. We'll copy that down and come across. Okay, so this last part, I don't think it's crucial, but we'll just write it down. So a dummy activity is an edge that must be added to avoid having a network that has 2 or more activities with the same name, or having 2 or more activities occurring in parallel. Because you can only have one edge. You can only have one edge for each activity. That's not critical, but we'll just put that in the notes as well. Okay, so that was a big video, and there'll be plenty of practice on those. Okay, bye.